Okay, good morning, students.
Good morning, sir.
Sir,
Good morning, sir.
Good morning. So, last class we were discussing about content delivery network or content distribution network, and the main objective was to minimize the delay and improve the quality of service by the users of the content servers. Okay. The evaluation metrics to evaluate the performance of content delivery network were also discussed at the end. So when we talk about network proximity, where the content delivery server is available, to which users are connected, we call that as access network, and we call that content delivery server as the surrogate server. Okay, surrogate server, which provides services directly to the client. The client doesn't require to reach to the origin server. Okay, and network hop, round trip time, internet mapping services, and these all are the metrics used to evaluate that. And similarly, surrogate load, that how many active TCP connections are there, and how far the content delivery server is able to manage multiple active TCP connections, and HTTP request arrival rate, that is lambda. Okay, you know Little's theorem, students? Do you know Little's theorem?
No, sir.
No. Every network student must know Little's theorem. It establishes the relationship between the arrival time, arrival rate, and service rate. And traffic engineering is completely based on this queuing theory. And to understand queuing theory, you need to know Little's theorem. Little's theorem is a very powerful theorem which is used everywhere in the queuing theory. And network is full of queuing theories. So each of you must know Little's theorem. Okay. So then moving on to content distribution internetworking. Now let us see. We talked about content delivery network, content delivery servers, its advantages, metrics, and so on and so forth, and comparing with caching scheme. Why it is required to interconnect the content distribution servers? Why there is a need for collaboration between caching proxies and content delivery servers or individual content delivery networks? And the answer to this question is fairly simple, as why do we internetwork? Why do we interconnect several networks? Why do we interconnect several networks? In general, why do we connect several networks? Suppose in an institute you have multiple LANs. What is the need to connect them, interconnect them?
Transfer data
For
for
better
information.
coverage.
sir,
Okay, so one is transferring data, the other one is
So for better coverage at low cost.
better coverage. Okay, you can have modular networks and for better manageability, And
So
next,
less traffic in case of the
reliability. If one network fails, if you have one large network and in contrary you have multiple small networks, which one will be better
the multiple small
from
networks.
reliability viewpoint? Multiple small networks, right?
Yes, sir.
So here the answer to my question is that why there is a need for interconnecting individual CDNs. The answer is that each CDN may be providing, or you can say each CDN provides a specific content. Now, if the CDNs can be interconnected, when the user moves from the coverage area of one CDN to other CDN, right? The user can access the contents without any hindrance. For example, when I am connected to a wired network and accessing some content, web content from Netflix content delivery server, let us suppose. Now, as I am moving from the fixed network to another network, but while walking, I come across, I decouple myself from the fixed network and rejoin a Wi-Fi network. Correct? Is this possible?
Yes, sir.
Yes, sir.
It is possible. So I rejoin a Wi-Fi network. So because of the change in network point of attachment, should there be any disruption in content delivery or content access?
No, sir.
No. So this we can meet only if when there is a provision at the back end to transfer the content from one
CDN to
server
another
to
CDN.
yes, CDN, right? So if the wired access point and wired Wi-Fi access point both happen to be served by one content delivery network, there is no problem. But if you happen to move from one region to other region where the regions are covered by different content delivery networks, then interconnection of these content delivery networks will help the user access the contents seamlessly. Right?
Yes, sir.
So as the second point says that in this slide, it says that greater reach, larger scale, higher capacity and increased fault tolerance. Right? What is this fault tolerance? It is the ability to tolerate a fault. If you have redundancy, then you will have more tolerant for fault. Okay?
Yes, sir.
What is this
Yes, sir.
redundancy? Redundancy in terms of the
Network.
CDN. Yeah. It can be network, it can be another CDN, right? Like that. So content delivery internetworking architecture looks like this, right? So there are content peering gateways which help these content delivery networks to interconnect and enable access to its users, right? So the arrows show that they are interconnected through the gateways, right? And this already we had discussed at the beginning of content delivery network. And the content which are not suitable for CDNs are personalized content, because if it is personalized content, then it will be very expensive for the content delivery network to maintain your personalized contents, right? So if it is a general content used by many users, then only content delivery networks are suitable, right? And mostly the type of content is not highly dynamic. Okay, it can be dynamic, but not highly dynamic, right? So for highly dynamic content, CDNs are not suitable. So it is suitable for both static and to some extent dynamic, right? But fairly suitable for static content only, right? And of course, if the content is very secure, CDNs are not suitable, because every user cannot meet the security requirements mandated by the content delivery network. Correct? So these are certain points where the content delivery networks are suitable for and not suitable, right? Any questions?
No, sir.
No, sir.
Okay. So again, we'll revisit the CDN versus caching proxies. Caching proxies are used by several systems, including ISPs, to reduce bandwidth consumption, because mostly the access to the content will happen locally. It is not required to access the network for accessing the remote server, right? So whenever there is a cache hit, whenever there is a cache hit, the access will take place locally. So that's how it reduces bandwidth consumption, right? And down the line, it operates reactively. What does that mean, operate reactively? Which means that the caching mechanism will observe users' access behavior to a particular object. And if that object is accessed frequently by its users, then it is a good point to save those objects locally. So saving an object or not saving an object highly depends on the user's behavior of or access behavior for that object, right? And if there is a cache miss, then only the new object will be brought into the cache. And to make place for the new object in the cache, some of the old objects which have not been used for some time can be the candidate for replacing. Did you understand? This is related to cache replacement policy. It means when you are bringing an object, new object into the cache, if the cache has space to accommodate the new object, fine, no issue. If the cache does not has a space for accommodating the new object, then one of the old objects need to be removed. Now, which will be the candidate old object for choosing to be removed? So here the time is the parameter which says that for how much time the object was not in use, not in use, and select that object for deleting so that space for the new object can be made. Since all this work post situation, so they are called reactive. That's why it is said that it operates reactively. Caching proxies operate reactively. Then again, coming down the line, caching proxies cater to the users and not to the content providers, right? How? Because the web clients will have lower access latency if there is a caching mechanism, right? But web servers do not get benefited, because web servers client base is larger and caching proxies client base is smaller, and it is mostly local. That's why caching proxies cater to their users and not to the content providers, right? Again, down the line, caching proxies do not give control of the content to the content providers because they are locally managed. okay, because they are locally managed. Any question with respect to caching proxies?
So the caching proxies cater to the web clients, I mean the users, because of the less storage required, not for the web servers because the traffic is more. Is that correct?
No, that is not correct. I will take you to a previous slide. I guess this one. You see, can you see the web cache basic operation slide?
Yes, sir.
So you see here the cache is serving only to these 6 clients.
Yes, sir.
So if you look at the web server, it may be connected to several such networks, several such set of clients. So caching scheme basically caters to the local needs.
Okay, so I was thinking like it also मतलब it provides benefit to the web server also, right? By reducing the traffic.
No, it is reducing traffic here in the sense that the client's requests are not going into the network. It is getting serviced locally if the object is available,
Yes, sir.
right? So that is
Yes.
how it is able to, caching scheme is able to restrict traffic getting into the network. Fine.
Yes, sir.
Any other questions, students? Other students?
No, sir.
Okay. So on the other side, the content delivery network or distribution network are used by the content providers to increase quality of service. Here, quality of service we mean low access latency, right? And how this low access latency is ensured? By implementing caching proxies, by placing surrogate servers, right? Surrogate servers or edge servers. So by distributing, when you distribute the load among several servers, the amount of traffic handled by each server will obviously get divided, right? So when the traffic handled by each server is divided by this, by the content delivery server is divided, what happens? Obviously, the queuing delay will be small, and depending on the location of the surrogate content delivery server, the access time can also be reduced. So in a way, content delivery networks maintained by content providers aim at improving its users' quality of service in terms of access latency, in terms of better turnaround time, and so on and so forth. Correct?
Yes, sir.
And in contrary to caching proxies operating reactively, CDNs operate proactively. Proactively in the sense that it learns that which group of users are accessing to which object, web object. So accordingly, those web objects are pushed onto the edge servers, so that pushed onto the edge of the network or edge servers or surrogate servers, right? So that users have better quality of experience. Since this is initiated by the content servers or content providers, we call it as proactive, right? So caching scheme is a reactive scheme. It tries to fetch the content from the content delivery servers, whereas the content delivery network, the servers push the content, right? The difference, see, one pulls the kind of objects and the other pushes the objects. So pushing is proactive and pulling is reactive. Fine. And CDN's third point, coming down in CDNs cater to the content providers and clients, right? In the sense that when you have content delivery networks, the content providers will have better availability and better turnaround time for the users, right? That way, CDNs cater to the content providers and clients, right? And the last point is, with respect to caching, we said that caching proxies do not give control of the content to the content providers, whereas CDNs do, right?
So the content provider decides that which content should be on the CDNs and the cache.
Yes, that is why we draw it from proactive. Proactively, CDNs do that.
Okay.
Any questions, students?
No, sir.
So we will discuss one more point here. The other terminology is that geo-blocking content delivery. Geo-blocking content delivery. What is it? As you said that let's say this is network 1 and this is network 2, right? And the user is moving along this direction and it is now connected to network 1, and as a result of its movement it is now connected. Okay, so this is new position, new location of user. Okay, so this is, let's suppose, wireless, this is wired. Suppose this is an example. This can be wireless, wired, or wireless, or wired. That can be, okay, anything. So when moving from one network to other network, the content delivered by the user is retained. Delivered to the user is retained. However, the new network to which it is currently attached to may be falling under another geographic location, territory, which prohibits the access to that content. Prohibits access to that content. In that case, there will be geo-blocking of content delivery. So geo-blocking content delivery happens when that particular geographic area is not allowed to deliver that content, right? So we call it a geo-blocking content delivery. For example, I'll give you a simple example that when you are on a IIITM campus, you will have access to all the digital resources that IIITM has subscribed to. Once you move out of IIITM's coverage area, you may not be able to access the content, right? What it means is that only the authentic users of IIITM or the students and faculty and staff of IIITM are allowed to access educational resources. That is the content. So whosoever is the content service provider restricts its users from accessing its contents outside its geographical coverage, right? Students?
Yes, sir.
So that is known as geo-blocking content delivery. Next is overload handling. Next is overload handling. As you said that content delivery network can be interconnected, okay? Can be interconnected. Two networks can be interconnected. So in case a content delivery network is see there is one expected traffic, and there can be unexpected traffic, right? So unexpected traffic is nothing but the flash crowd that may drive the drive a network or content delivery server to a load condition which it cannot service and termed as overloaded, right? So in that case part of the load can be routed to content delivery network B. Are you getting?
Yes, sir.
So flash crowd maybe that may happen due to the content popularity. Okay, if the content is very popular, then there may be many users thronging into accessing that content, and that will lead to flash crowd and what to say spike in load on CDN, So in that case, to maintain the quality of service, some of the flash crowd can be moved to content delivery network B. Okay, so some amount of the flash crowd can be moved to CDN B, right? Also, this is called overload handling. How the load is additional load from content delivery network A is moved to content delivery network B. This is basically traffic rerouting, right? Is this clear? You understand what is traffic rerouting or the request rerouting? The requests coming here will be rerouted to CDN B. So this is called traffic rerouting. Or you can say it is request rerouting. Fine?
Yes, sir.
Traffic or request rerouting. So this is how overloading on content delivery networks are handled. Sometimes it is moved to another content delivery network or maybe moved to the origin server. Fine. Also, you may see that there will be different peak times. Different peak times of two CDNs. CDNs. What do you mean by different peak times? Different traffic peak time. Forgot this. Different traffic peak time. What do you mean by this?
Sir, load on them. A trap.
Yes. Load on them. Yes, you are right. Go ahead.
एक्चुअली सर जो रिक्वेस्ट इन पे आएगी तो उस हिसाब से जो एक किसी पर्टिकुलर टाइम पे तो उस टाइम पे किसी फ्रीक्वेंट टाइम पे ज्यादा रिक्वेस्ट आएगी तो लोड बढ़ जाएगा सीडीएस पे.
Different traffic peak times of CDNs. मैंने खाली एक सिंगल सीडीएन नहीं कहा.
So different CDNs catering to different types of content providers may have different peak times.
Yes. Different content providers may have different peak times. For example, Netflix, अगर हम एग्जांपल लेते हैं तो यूसेज बिहेवियर यूएस और इंडिया को अगर देखेंगे तो सेम नेटफ्लिक्स सर्वर व्हेन कैटरिंग टू यूएस यूजर्स फ्रॉम यूएस एंड यूजर्स फ्रॉम इंडिया, द पीक टाइम्स ऑन द नेटफ्लिक्स सर्वर विल बी डिफरेंट. है कि नहीं? ट्रैफिक पीक टाइम, क्योंकि
Yes,
हम
sir.
लोगों का 12 घंटे का डिफरेंस है, टाइम डिफरेंस है. हो सकता है.
Yes, sir.
Yes, sir.
So different peak times of two CDNs can be taken advantage of, and one CDN's capacity can be utilized by the other. क्या समझ में आया?
Repeated.
Different traffic peak times of two CDNs can be taken advantage of. क्या ये सही है?
Yes, sir.
Yes, sir.
And one CDN's capacity can be utilized by the other. क्योंकि एक जब ओवरलोड होगा दूसरा लोड नहीं होगा उस पे, क्योंकि पीक टाइम उनका अलग है.
Yes, sir.
तो दूसरा
We can
जब
route-
अंडरलोडेड होगा तो उसका कैपेसिटी को हम जो ओवरलोडेड मशीन है उसके द्वारा यूज किया जा सकता है. ठीक है? एंड दिस इज नोन एज डायमेंशनिंग. दिस इज नोन एज डायमेंशनिंग. ठीक है?
Yes, sir.
तो हमने मोटा मोटी क्या चीज पढ़ा आज कि इंटरकनेक्शन ऑफ कंटेंट डिलीवरी नेटवर्क्स, एंड देन जियो ब्लॉकिंग ऑफ कंटेंट डिलीवरी, ओवरलोड हैंडलिंग एंड फाइनली डायमेंशनिंग. ठीक है?
Yes, sir.
और इसके ऊपर
Sir,
यस प्लीज.
the example which you take of Netflix, so Netflix US and Netflix India both will be using different CDNs, or because they are the same content provider, they might be using the same CDN also.
No.
ऐसा हो सकता है.
सेम सीडीएन हो सकता है, लेकिन जो इंडिया के यूजर से उनके लिए सरोगेट सीडीएन तो होंगे ना.
Yes, sir.
सरोगेट सीडीएन होंगे और ऊपर से यूएस के कॉन्टेक्स्ट से आपका आता है जियो ब्लॉकिंग आता है. हेलो
Sir, audio lost, sir.
सर आपका ऑडियो नहीं आ रहा है.
ऑडियो नहीं आ रहा है.
सर अब आ गया है. बीच में कट गया था.
ओके. मैं ये कह रहा था कि दो जैसे हमारे कंट्री के लिए जो सीडीएन होंगे नेटफ्लिक्स के, ठीक है, वो सरोगेट सीडीएन हो सकता है। कैन यू हियर मी?
सर आवाज से बीच में कट जा रहा है सर, आ नहीं रहा है बीच में।
सरो इंडिया के जो नेटफ्लिक्स हो सकता है होगा वो सरोगेट सीडीएन होगा।
यस सर।
राइट, सरोगेट सीडीएन
यस सर।
होगा। एंड जो कंटेंट यूएस में एक्सेसिबल है यूजर्स को, हमें वो कंटेंट एक्सेसिबल नहीं है। दैट्स वेयर वी से दैट द कंटेंट्स आर जियो ब्लॉकिंग।
यस सर।
ठीक है, तो आप यही पूछ रहे थे?
यस सर, यस सर।
राइट, और कुछ?
नो
We are
सर।
not going in detail of content delivery network, but just एक रहना जाए छूट ना जाए इसलिए हमने इसको कवर कर लिया। ठीक है, तो इसमें बहुत सारे स्कीम्स आते हैं कि किस तरह आप रेप्लिकेट करेंगे सीडीएन्स को। और रेप्लिकेशन में मोस्टली क्योंकि ये स्टैटिक कंटेंट होता है, तो स्टैटिक मतलब ऐसा नहीं कि थ्रू आउट स्टैटिक, डायनेमिसिटी इसका कम है। तो कम डायनेमिसिटी जब है तो रेप्लिकास किस तरह अपडेट होता है, ठीक है, ये सारे बहुत सारे स्कीम्स है, वो सब चीज हम पढ़े नहीं। ठीक है, so we have just left our discussion on CDN to the introductory level, just to familiarize what it is, what are the issues, and how it looks, and what is the purpose, right? So the scope of our discussion was limited to only this. So with this we complete this course here, and tomorrow we have exam, and that will be, the course will be, I think the transport layer क्या था लास्ट में?
जैसे ट्रांसपोर्ट ले।
हाँ, ट्रांसपोर्ट लेयर रहेगा। ठीक है, और
28
अभी जो सीडीएन के ऊपर जो है वो नहीं रहेगा बिल्कुल।
सर आपने 28 बोला था।
हाँ 28 ना, परसों 28 है।
यस सर।
हाँ, सैटरडे को 28 है, सैटरडे को होगा एग्जाम। ठीक है, और कल नहीं होगा क्योंकि खत्म हो गया। अगर आप लोगों का कुछ अगर डाउट वगैरह है तो मुझे व्हाट्सएप कर सकते हो आप, और अगर ज्यादा लोगों का डाउट है तो हम एक सेशन रख सकते हैं जिसमें हम लोग गूगल मीट के द्वारा डिस्कशन कर सकते हैं।
ओके सर।
ठीक है, और कुछ?
नो सर।
ओके,
सर आपने एक बार बोला था आप ऑनलाइन कोई कोर्स बताएंगे, सर उसका आप बता सकते हैं कौन सा था वो, तो अभी इन वेकेशंस में कर सकते हैं।
अभी जो एग्जाम के बाद करने के लिए?
यस सर।
yes.
ठीक है, मैं बता दूंगा। ठीक है, मुझे अभी तुरंत ध्यान में नहीं आ रहा है, मैं बता दूंगा। ठीक,
ओके सर। ओके, थैंक यू।
राइट राइट।
थैंक यू सर।